Hello students, good evening everyone. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So those who are watching the particular session, just mark your attendance here. So in the last two sessions, we have discussed about the nomenclature of carbon compounds, right? IUPAC nomenclature of different carbon compounds, including the functional groups. So today we are discussing the topic of isomerism. This is a new important topic in the case of carbon compounds. The last two classes also we have discussed about this topic. Now I am repeating the same topic again, isomerism. So I hope you understand about the nomenclature of different compounds. Do practice on the nomenclature of compounds, then it will be very easy for you there. Hi Arush, good evening, welcome to the session. Now quickly start with our today's session about the isomerism, which we have already discussed in the last class also. So what do you mean by isomer or the process of isomerism? In the case of IUPAC nomenclature or the naming, we have seen like that for the different carbon compounds, they have structural formula, molecular formula and condensed formula, right? So in the case of isomers are the different compounds which is having the same molecular formula but difference in their structure. Right? So same molecular formula but difference in the structures or position of the groups. So this is the exact meaning or definition of the isomers or the process of isomerism. Same molecular formula but have different structures or stereo positions. So based on that, the isomers can be classified into two types. One is structural isomerism and another one is stereo isomerism. In our syllabus, we don't want to focus more on the stereo isomerism. Just for a reference, I am giving a idea about here. This is the stereo isomers are the compounds which is having the same molecular formula but only difference in their orientation of the group. When you are studying about the stereochemistry, you will get an idea about that. So in order for a reference, we need to identify that isomerism can be classified into two types. One is stereoisomerism and another one is structural isomerism. So in our grade 10 syllabus, we need to focus detail on the structural isomerism. So what do you mean by the structural isomers or structural isomerism? What is the difference there? Only in the structure difference, right? They have the same molecular formula but only difference in their different structures. This is the flow chart of the isomerism in carbon compounds. Isomers can be classified into structural and stereoisomerism. In our examination point of view, we need to focus on structural isomerism can be again divided into chain isomerism, position isomerism and functional group isomerism. Let us see in detail. So what do you mean by chain isomerism? What is the difference in the chain isomerism? Same only that the same molecular formula but the difference in their arrangement of carbon atoms. Arrangement of carbon atoms or the arrangement in the chains, right? It is also known as nuclear or skeletal isomerism. So if you are asking about the skeletal isomerism, it is simply mean to that of the chain isomerism only. Let us see by examples. So this is the isomers for the C4H10. Which molecule it is? What is the IUPAC name of this compound? C4H10. C4H10. So this is the molecular formula, right? 4 carbon atom is present. What will be the root word for this compound? Bute, right? It contains only single bond, so it will be butane. So this will be the structural formula of the butane. So what you are observing here, this will be a long chain structure, right? The first one will be a long chain structure of butane. Clear? this is a 4-carbon compound. For the 4-carbon compound, the root word will be but only, and it is contain only single bond, so suffix will be ane. So this is a longest chain structure for the butane molecule. Okay, I hope you understand about the first structure. Then what is the difference between the second structure? What are you observing in the second structure? If you are finding the longest chain, it will be 3-carbon compound, right? 3-carbon compound. So what you are observing here? Word root will be prop, right? Then the second position, if you are doing the numbering here, it will be 1, 2, 3. So in the second position, CH3 group is present, which means it is methyl group, right? So prop 2 methyl. Okay, how we can name this compound? Hi Harleen. How we can name this compound? If you are having alkyl groups are the branches, right? We need to do it as a prefix or suffix. Prefix, right? So this is the methyl group which is present in the second carbon. So we need to give it as a prefix 2-methyl. 3-carbon compound is prop, right? Word root will be prop. Only single bonds are present, so suffix will be ane. So 2-methyl propane is the IUPAC name of this compound. Is that clear? Arush, what do you mean by alcohol or propanol? It should contain the functional group of OH, right? Are you able to see any OH group in this compound? No, right? There is no any OH group. This is CH3 and the remaining are hydrogen. So this is not an alcohol group. So this is known as a 2-methyl propane. Then what is the molecular formula here? Total 4 carbon, right? 1, 2, 3, 4. The yellow ones are the carbon. C4. What is the number of hydrogen here? Again, 3 plus 3, 6 plus 3, 9 plus 1, 10, right? C4H10. So which means these are the two compounds having the same molecular formula but difference in their structures. This is known as the chain isomers of butane or C4H10. Is that clear? Is that clear? Now try to find out the count down the number of hydrogen atoms here, right? 1, 2, 3. Again in the case of CH3, 3 hydrogen is present here. So 3 plus 3, 6, 7, 8, 9, 10. Clear? Arush? Try to find out the isomers of C5H12, which means these compounds containing 5 carbons and 12 hydrogen atoms. First, you need to write down the longest chain structure for the C5H12. Five carbon, right? Each carbon is attached by single bonds. The remaining valencies are satisfied by the hydrogen atoms, right? Clear? So what you are observing here, 5 carbon, C5. The number of hydrogen atoms will be total 12, right? C5H12. This is known as the pentane or normal pentane. The longest chain structure of the pentane is known as normal pentane, represented as small letter n pentane. Clear? Then what will be the other possibility for the isomers of the same compound with formula C5H12? Count down the number of hydrogen and carbon atoms here. Is it same? C5H12. This is also C5H12, right? 5 carbon atoms. We need to consider this carbon also. So 1, 2, 3, 4, 5 carbon atoms and total 12 hydrogen atoms, right? So molecular formula will be C5H12. What will be the IUPAC name of this compound? IUPAC name of this compound. Okay, in the last class we have seen the IUPAC name of the carbon compounds, right? So try to find out the IUPAC name of this compound. No answers? First we need to identify the longest chain, right? So this will be the longest chain with root word of but, right? So I am starting the numbering here 1, 2, 3, 4. Right. So root word will be but. So what you are observing here, in the second carbon there is a methyl group, right? This is our branching here, methyl group. So the name will be 2-methyl because alkyl group is act as a primary suffix here. 2-methyl butane, right? All the hydrogen atoms are in between the single bond. So 2-methyl butane will be the IUPAC name of this compound. Is there any doubt? Now I will write down another structure for this compound. Try to find out the IUPAC name of this compound. What is the molecular formula of this compound? What is the molecular formula of this compound? How many number of carbon atoms are present and how many number of hydrogen atoms are present here? C5H12, right? So this is the C5H12. So what will be the name of this compound? IUPAC name of this compound. So what you're observing, we need to find out the longest chain, right? Longest chain. So this will be the longest chain. We need to do the numbering here. 1, 2, 3. The root word will be prop, right? Then in the second position there will be 2 methyl groups are present. So in order to write down the name here, we need to add the position of 2 methyl groups. So it will be 2, 2, dimethyl. Di stands for 2 methyl groups are present. Dimethyl propane. Is that clear? Arush, is that clear now? So these are the 3 isomers of the C5H12. So what you are observing here, in all the 3 compounds they are having the same molecular formula of C5H12, right? But the only difference is that this is the longest chain compound. This will be the branched compound with 2-methyl group, and this is the another branched compound with 2,2-dimethyl group, right? So these are the possible isomers for the C5H12 or the pentane. Clear? According to IUPAC, what was our rule to name the compound? We need to identify the longest chain, right? Longest chain. So here, if you are taking here, anyhow, if you are counting here, you will get an only 3 carbon compound, right? Longest chain will be a 3 carbon compound. So it will be prop only, according to IUPAC. Okay, I hope you understand. Clear? So this is a table. We need to identify the number of chain isomers. For the C2H6, there is no any possible chain isomers here, and C3H8 and propane also there is no any chain isomers. So if you are asking about the number of chain isomers for the butane molecule, it will be 2. We have already seen the structures, right? Then for C5H12 or the pentane, it will be 3. Clear? Then what about the higher compounds like hexane, it will be 5. Heptane, it will be 9. Then for C8H18, octane will be 18 and so on. So the number of, as the chain length increases, as the carbon compound chain increases, the number of chain isomers also increases. Clear? So these are the two structures we have seen in the chain isomerism. What we are talking about here, it is asking about the alkanes, right? The last class also we have seen alkanes have the general formula of CnH2n plus 2, right? So if you are taking C6, what will be the number of hydrogen atoms? 2 into 6, 12 plus 12, 14, right? C6H14. Clear? Now let us talk about the another type of structural isomerism, that is the position isomerism. So what do you mean by position isomerism? Same only, they have the same molecular formula, difference in their position of functional groups or the multiple bonds. What are the multiple bonds? Double or triple bond, right? So if any of the compound which contain double or triple bond, they need to change their positions, right? So that they will get the position isomers. So position of a functional group or the multiple bonds or substituents. The same carbon chain are called position isomerism. Clear? So let us see the examples. So what are you observing here? Arish, you need to revise our last session. We have seen the general formula of alkanes, alkenes and alkynes. There is a general formula for different compounds. So what you are observing here in the case of these two compounds? This is the functional group, right? OH is the functional group or hydroxy group is the functional group here. So what you are observing here, we need to do the naming here, which is the longest chain in this first compound. So this will be the longest compound, right? So when we are doing the IUPAC naming of the functional group, we need to give the lowest number for the functional group attaching carbon atom, right? So I am starting the numbering from here, 1, 2 and 3. So what you are observing here, the OH group is attached to the first carbon atom of this compound, right? So these are 3 carbon compounds. So word root will be prop. This is propan. Position of the OH is 1, propan 1 or propanol. Clear? Then what will be the IUPAC name of the second compound? What is the difference here in between first and second structures? Again, this is also 3 carbon compound, right? Longest chain will be 3 carbon compound. So if I am starting the numbering from here or there, both are same, right? The OH group is attached to the second carbon atom of the compound. So it will be root word will be prop only, 3 carbon compound. So propan. Position of hydroxy group is second carbon. So propan 2 all will be the IUPAC name of the second compound. Clear? So from the name we can identify that there is only the change in the position of the OH group. First is in the first carbon atom and second is in the second carbon atom. Right? That will be our examination or the example for the position isomers. Clear? Then what about these compound? Can we call it as a position isomer? So try to find out the naming of this compound. It's already given here. So this is the 1, 2, 3, 4 carbon compound, right? 4 carbon means butane will be the root word. What you are observing here in the second position of the carbon atom, an OH group is attaching, so it will be butane 2-ol, right? Butane 2-ol. This is the IUPAC name of this compound. Similarly, if you are taking this compound, what you are observing, this OH group is attaching to the first carbon atom of this compound. Again, 4 carbon compound, word root will be butane, position of OH is at the first carbon, and suffix will be oil for the hydroxy group or alcohol. Clear? So we can say that these are the position isomers, right? These are the position isomers with the difference in the position of OH group. Then I have a question for you. If we are asking about the position isomers of pentene, okay, we can call this as butanol also. Butane 1-ol or butanol is also fine. So what will be the position isomers of pentane? 5 carbon, right? What do you mean by the suffix YNE? Whether it is single bond, double bond or triple bond? Pentine. Okay, try to revise these topics on daily basis, otherwise we will forget about this. Try to practice the questions. While we are reading, we will not get an idea about that. So this will be the structure of pentane, right? So what you're observing here, I need to do the numbering here. So I'm starting the numbering from here, 1, 2, 3, 4, 5, right? So the longest chain will be 5 carbon compound, so pent will be the word root here, right? Pent will be the word root. So what is the position of triple bond here? Position of triple bond is in the first carbon, right? So pen 1 ion will be the name of this, IUPAC name of this compound. Is that clear? Then what about this structure? There is no necessary to start from left to right. The only point is that if you are taking any of the functional group or multiple bond, we need to get the least number for the functional group we are using. For example, here we are using the functional group as triple bond, right? So we need to start the numbering in order to get the number for the triple bond as least number. So what is the name of this compound? So I'm starting the numbering from here. So if you are starting from here to here, it will be getting number of 3, right? Sorry, number of 4, which means we need to get the lowest number here, so it will be 2 only. I am starting from my left to right. So what you are observing here, again 5 carbon compound, word root will be pent. What is the position of triple bond in the second carbon, right? So pent 2YNE. That will be the name of this compound. So what is the difference here? Only the difference in the position of triple bond. In the first compound, the triple bond is in the first carbon. The second compound, triple bond is in the second carbon. Is that clear? Is that clear? Do you have any doubt? Now let us discuss about the functional group isomerism. So here in the case of functional group isomerism, the name itself suggests that there is a difference in the functional group. So in the last class we had discussed about the different types of functional groups, right? Started from alcohol, aldehyde, carboxylic acid. So here it is based on the functional groups. It will be having the same molecular formula but different functional groups. So let us see the examples here. This is the molecular formula of C2H6O, which means 2 carbon atoms, 6 hydrogen atoms, 1 oxygen is present. So what is the possible structures? Which compound it is? OH group is present, right? If OH group is present, we can call it as an alcohol. So 2 carbon compound, so it will be ethanol or ethyl alcohol. Clear? Ethanol or ethyl alcohol, 2 carbon compound. This OH is attached to the first carbon atom, so we can call it as ethanol, either ethane 1 or ethyl alcohol also possible. Then what will be the another structure? Which is this functional group we have seen. This is the ether group, right? Ether group. So it will be CH3 or CH3. The naming will be dimethyl ether. 2 methyl groups are present, right? So dimethyl ether will be the naming of this compound, or otherwise it is also known as methoxymethane. Clear? Methoxymethane. So we can say that alcohol and ethers are the functional group isomers. Clear? What is the molecular formula here? It will be C2H6O, right? C2H6O. Here also it is C2H6O. Okay, I hope you understand. So ethers and alcohols are the functional group isomers. Now let us see another example here. C3H6O. So what about this compound? Which is the functional group here in this first compound? The first compound, this is a functional group. What you call it as this as a functional group, CHO group. Aldehyde, right? CHO group is known as the aldehyde. So the longest chain is 3 carbon compound including the CHO. So it will be, word root will be propan, right? Propan. For the CHO, the suffix will be AL. So propanal is the IUPAC name of this compound and the common name is propanaldehyde. The molecular formula will be C3H6O. Then what about the second compound? Yes, it is propanal. So what is the second compound? What is the functional group here in the second compound? C double bond O, right? Yes, C double bond O is known as the ketone group. 3 carbon compound. So word root will be propan and the suffix will be ONE for the ketone compound. So this will be the IUPAC name of compound, propanol, and the common name is acetone. Again, C3H6O will be the molecular formula here. What about the next case? Functional group is a double bond, right? Functional group is a double bond. So this is a 1, 2, 3 carbon compound, 3 carbon compound in which OH group is present in the first carbon and a double bond is present in the second carbon. So now to name these compound, we need to focus on the position of double bond as well as OH group. So here we need to give the numbering according to the priority order. Acetone is a type of ketone which contains C double bond O group. It is the simplest ketone we are using in the laboratories. So here when you are asking about the priority order, if you are having OH or double bond together, we need to give the least number for the OH group according to priority order. Right? So here we need to give the least number for the OH group. So I am starting the numbering from here, 1, 2, 3. So the word root will be prop, right? Word root will be prop and the position of OH will be 1 and position of double bond will be 2. Then while giving the IUPAC name, we need to give the alphabetical order, right? E will be comes first before O, right? So the name will be prop 2 in 1 all, which means it's a 3 carbon compound in which in the second position there is a double bond and the first position there is an OH group. Is that clear? Is that clear or do you have any doubt? Okay, fine. So this is the common name is known as the allyl alcohol, which means that an OH group is attached to the carbon atom, which is nearer to the double bond. Just for a reference. Okay, I hope you understand. Again, the molecular formula will be C3H6O. So these are the three different types of functional isomers of the compound having the molecular formula C3H6O. One is aldehyde, other one is ketone, and the last one is allyl alcohol or unsaturated alcohols. These are the another example. So what you're observing here, 4 different compounds, right? Sweetie, which point I want to repeat? In this compound, right, these are the compound which is having the molecular formula of C3H6O. So what you're observing in the first compound, this is a functional group of CHO. Aldehyde group is present, right? So in the case of second compound, there is a ketone group is present as a functional group. So if you are focusing on the molecular formula, it has the same molecular formula, but the difference in their functional group. First is aldehyde and second is ketone. Then what about the third compound? Third compound means I have given the naming of IUPAC. According to IUPAC, I have given the naming of this compound. So what you are observing here, this is an allyl alcohol, right? Allyl alcohol, which means that a double bond is used as the functional group here. Now these are the another examples. So what you're observing in the case of first compound, functional group is COOH. So what do you mean by COOH? Carboxylic acid, right? Carboxylic acid, the name will be 3-carbon compound with suffix of oic acid. So this is propanoic acid. Molecular formula will be C3H6O2. Then what about the case of second compound? COO is the functional group because it is an ester group. Let's watch on our last session, recorded session, that will be explaining about the functional groups. So it will be COO or ester. So the naming of this compound will be methyl ethanoate. For esters, it will be OAT will be the suffix, methyl ethanoate. Then what about here? 2 functional groups are present, right? OH and CHO. So according to priority order, CHO will be more prior than the OH. So we need to give the least number for the CHO group. So it will be starting from here 1, 2, 3. So what you are observing here, 3-carbon compound. The second position there is an OH group and first position there is an aldehyde. So it will be 2-hydroxypropanol. R stands for the aldehyde here. What about the last compound? Irish, I will come back to you after completing this. So what about this compound? Ketone group is present here. Ketone group is present. Ketone group is present here. So what you are observing here? So hydroxy group is also present here along with propanone, right? Propanone means it is a ketone. We need to give the position of the hydroxy group here. So if you are having the OH and ketone together, ketone will have the least number here. So I will start the numbering from here only. 1, 2, 3. So it will be 3-hydroxypropanone. Okay, I hope you understand the naming of this compound. So this is our compound, right? This is our compound. So OH group means alcohol is present here. So what you're observing here, this OH group is attached to a carbon, right? This is our carbon. And this carbon is attached to a double bonded carbon atom. Are you getting my point? Arush, I'm explaining about the allyl alcohol, right? Allyl means the OH group is attached to a carbon atom which is nearer to the carbon double bond. Clear? This OH is attached to this carbon atom which is nearer to the double bonded carbon atom. So that is known as the allyl here, and this is an alcohol, so this is known as the allyl alcohol. Is that clear? Okay, fine. So here, according to priority order, ketone is more prior than the OH group. So we are giving the name as hydroxy for the OH. Okay, I hope you understand. That's why we are using 3-hydroxy here in the case of OH group. So if OH is more prior, we can call it as an alcohol. We can give the name as all here. Okay, GK, now I am explaining the homologous series. What do you mean by the homologous series? For example, I am taking an example of CH4 molecule, right? I am taking an example of CH4 molecule. Now I am taking an example of C2H6. What these compounds? These are alkanes, alkenes or alkynes. We have discussed in the last class. Are you sure? Arush? CH4, C2H6. CH4 is known as a methane molecule. So you need to focus on the naming of the compound. CH4 means carbon containing single bonds only. So these are the alkanes. First one is methane. Second one is ethane, right? 2 carbon compound. So homologous series are the type of compounds which contain same type of functional group or the same type of bonds here. For example, if you are asking about the case of alkenes, these are the 2 type of compound, 2 type of alkenes. The only difference is that there will be a difference of CH2 molecule. Are you getting my point? So if you are adding CH2 to the CH4, we will get the C2H6 molecule, right? Is that clear? GK. These are the type of homologous series in the case of alkenes. Similarly, in the case of alkenes, alkynes and all the functional group also we can find out the homologous series. The only difference is that they have a difference of CH2 molecule. Clear? Now let us practice some questions based on the isomerism part. Here is the first question. Which of the following is a pair of functional isomers? Functional isomers. And options are given here. Ethanol and dimethyl ether, propane and butane, 1-butanol and 2-butanol, and cyclohexane and hexane. What will be the answer for this question? Asking about the functional isomers. So what is the difference in the functional isomers? So option A will be the correct answer, ethanol and dimethyl ether, which means in the case of ethanol, the OH will be the functional group, alcohol, right? In the case of dimethyl ether, ROR, oxygen is the functional group here. So this is the example of functional group isomers. I have already repeated, in the case of functional group isomers, there will be the only difference in their functional group. First is alcohol and second one is ROR. Then in the case of propane and butane, we can call it as homologous series. What is the molecular formula of propane? Propane means 3 carbon compound with single bonds only. Generally, the alkane have the general formula of CnH2n plus 2, right? So if you are focusing on the propane, number of N will be the number of carbon atoms, that will be C3 here. So C3H8, right? C3H8 and it will be C4H10. Clear? So what is the difference here? C3H8 plus CH2 will be C4H10. So the difference between CH2 molecule is known as the homologous series. Clear? Here is our second question. What type of isomerism is shown by 1 propanol and 2 propanol? Yes, positional isomerism, right? Because in the case of 1 propanol, OH is present in the first carbon atom, and in the case of 2 propanol, OH is present in the second carbon atom. So this is an example of position isomers or position isomerism. Now here is the next question. Which of the following pairs are chain isomers? Chain isomers. In order to answer this type of question, you need to try to write down the structure of this compound. So what will be the answer for this question? Chain isomers, only the difference in the structure. One will be long chain structure and another one will be branched chain. Arush, you need to focus more on the functional group part. I thought you missed the class. So ethanol and ethanoic acid has a difference in the functional group, right? Ethanol means it is CH3CH2OH. And ethanoic acid is CH3COOH. So what is the difference here? Functional group. One is carboxylic acid and another one is OH. So this is an example of functional group isomers. We need to focus on the chain isomers, right? Chain isomers. So what will be our answer? First one, pentane and 2-methyl butane will be the example of the chain isomers. So if you are trying to draw the structure of this compound, so it will be the condensed formula of the CH3, CH2, CH2, CH3, that is pentane. Then if you are trying to write down the 2-methyl butane, it will be 4 carbon compound, in which second carbon there is a methyl group present. So it will be CH3, right? So if you are focusing on the molecular formula, we can see that in these two compounds they have the same molecular formula, but the difference is that it must be containing different branches, right? Okay, I hope you understand. Here is our next question. There is no any option for this question. Select the saturated hydrocarbons from the following. Different molecular formula of the compounds are given here. We need to identify the saturated hydrocarbons. So in the last class, we have discussed the classification of hydrocarbons, right? We can classify the hydrocarbons into saturated and unsaturated. So what do you mean by saturated hydrocarbons? What is the general formula of the saturated hydrocarbons? Based on that idea, you will get the answer for this question. And options are given here: C3H6, C5H10, C4H10, C6H14 and C2H4. So these are the general formula of the alkane, alkene and alkane. So these alkane means only single bonds are present, so they are known as a saturated compounds. Then these compounds, alkenes and alkanes together, known as the unsaturated hydrocarbons. They may contain multiple bonds, either double bond or triple bond. Clear? So what is the answer here? What will be the answers here? If you are taking C3H6, C3H6, right? So C3H6 means if you are taking 3 here, what will be the alkane for the C3 compound, 3 carbon compound? It will be C3H8, right? C3H8. So we will get the answer is C3H6 is alkene. Similarly here, C5H10, right? 5 carbon, double the carbon of hydrogen atom, C5H10 is an example of alkene. Then what about here in the case of C2H4? C2H4 means 2 carbon atom, again 2 into 2 minus 2, that is equal to C2H4. This is an example of alkyne. Then the remaining 2, that is C4H10 and C6H14 are the examples of saturated hydrocarbon here. Is that clear? Here is our last question. Write the name and structure of an alcohol with 4 carbon atoms in its molecule. You need to write down the name as well as structure of this compound with 4 carbon atoms, and it is an alcohol. Name is butanol, right? So what will be the structure? I will write down the structure here. You need to check whether it is correct or wrong. 4 carbon, right? So 1, 2, 3, 4. What is the functional group here? In the case of alcohol, OH, right? So I am putting OH here. Then the remaining we need to focus by the hydrogen atoms. Valencies are satisfied with the hydrogen atoms. Clear? This will be the expanded structural formula, or we can condense this formula as CH3, CH2, CH2, CH2OH. Is that clear? Is that clear? Do you have any doubt? Okay, that's all about from my side for today. Let's talk about the summary here. We have seen the case of isomerism, right? We have seen the phenomena of isomerism. We have seen different types of isomers, structural as well as stereoisomerism. In the case of structural isomerism, we have seen chain isomers, position isomers and functional isomerism. So we need to focus on the more practice question, to identify the stages here. Okay, do you have any doubt? If you have any doubt, you can ask, otherwise we can wind up the session for today. Harish, you need to focus on the naming of the compound first, then only focus about the isomerism. Then you will get an idea about the structural formula, how to write down the structural formula. First write down memorize the table here. We need to identify the number of carbon atoms and the word root there. Then try for the IUPAC nomenclature, then go for the structural formula. Okay, I hope you guys enjoy the session. If you really like the session, hit the like button, share these lives to your friends also, subscribe our channel. And if you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. Okay, thank you so much all of you. See you in the next class. In the next class, I will be coming back with the chemical properties of carbon compounds. So we have successfully completed the nomenclature as well as the isomers of the carbon compounds. So see you in the next class. Bye bye.